Okay, hopefully everybody can hear me. I'm using Teams to record this. If it doesn't work very well, let me know and I'll try to find another software. My name is Jake Scutchamera. I'm the program manager for NanoRacks internal payloads program and also the overall mission manager of the Saudi Space Commission Space Agency payloads going on the AX-2 mission. So this video is for the tracker software, specifically for the flight kits. It's a free to download software. The link is in the training manuals for the kit, and there's a few various tutorial videos that you can watch that I've also provided to Michelle. So once downloaded, students can come into here. What they would do is use their phone to take a video of whatever they want to track. This would be the kites. And then they would move that file. They could upload it through Google Drive or through just connecting it to their computer somehow, but basically move the file to the computer's file repository and then go here to open a file. This might take me. I need to figure out where I have my file. Okay, usually they'd probably be looking for an MP4 file, which I have here. So then Tracker will take its time to install this or upload this file. This can take a couple of seconds to a minute or so. And we essentially have this graph here. So for these purposes, I didn't have access to a fan. So I couldn't really set the kite up in that way. But so what I'm basically using is gravity as the fan in a way, and just to show you the purposes of the video. What students are first going to want to do is take this. This is the time bar, so you can see the video plays here. This is to cut the video, basically. So, we want to focus on the movement portion, so we don't really care about all of this. You can see I did a quick test run. So essentially, we want to get this to right before it's going to start the video or the motion that we want to track. I think right there is a good starting point. And then this, on this end, we want to track once it lands back to the ground. Once it has completed its motion, and then we'll go through here and play this video and see what that looks like. Yeah, I think that's pretty good. I'll just move this a little bit further just to make it a little faster. I like to set this looping tool on here. So, this will just consistently play through this little loop. I like to do that. What students will do next, and what I've done in this video here is this is a 1 meter of length. This would be dependent on whatever it is from so let's say the fans here, and the extent of the kite is what we would want to calibrate Tracker with. So Tracker, we're going to tell Tracker that this is 1 meter here, and Tracker will be able to record that. So we go to this calibration tool, and we say new stick, and we just tell Tracker that this is 1 meter. Okay, and that's what it's already saying here. You can change this value to whatever you want. All Tracker's doing is it's going to use that to plot all this stuff. And then I like to also use this orientation tool to also help Tracker with the axes. So what this is going to do is record the motion of this kite as in relevance to this axis. You could also set another calibration stick in the y-axis here to see its deviations in that regard. Tracker will do that. It's just with the calibration, it's nice. So if you wanted to, you could say another meter here and another meter here or what have you. I'll leave that up to the teachers if they want to perform that. And I think this could all be optional also. This is a little extra to do here. So next we're going to say, let's start the video back to the beginning. We're going to tell Tracker to track, and we'll say new. There's a whole lot of stuff we can do here, but I think for these purposes, just a point mass is probably best. And now once we press the shift button on the keyboard, you see we get a little new cursor. So here's this cursor. We hold shift and we get this little crosshair. And what this is the tracker. So at each point we will put a point mass. And essentially it will click through the frame. So I'm kind of focusing on the center of the kite, in trying to follow that point mass as the kite travels, as it steps through each frame in motion. So essentially what the students are doing here is tracking the motion of this one point on the kite through each frame. Step through each frame until it's complete, and that's completed based on the time frame that we specified earlier. So I'm still tracking this through here. Now this is essentially done, but just for completion, I'll keep tracking this a little bit. And so what will happen now, and you can see that it tracked this graph, right? So, well, we should probably delete this. Anyway, so it will show that it'll graph this out here. And so this is the x-axis. So this is here. And as we can see, the kite falls. And it actually, if it were falling, if it didn't have wind resistance, we would see a perfectly straight line here. Actually, the fact that it is a kite and acting as a parachute in this scenario is we do see this kind of rounded curve here. This is more acting strictly as a, because it will fall at the same, it should accelerate at the same speed, but here we're seeing a slower acceleration. And we can look at this many different ways, and students can really look into this. But basically, this is the kite is falling here. And there's a little bounce at the end, and then it pretty much stays at its maximum length. These are deviations from the y-axis. So we saw in the beginning there that the kite kind of really sways to the left of the camera, or to the bottom of the camera in this view. And then teeters around a bit and then sways back into the center and kind of moves around. So that's all these graphs are showing, is the deviations from the axes. And then if we click play through this video, we can follow the tracking that we made, and it will create this really nice thing as it steps through this graph for us. So that's really the extent of it. I think students can play around with this quite a bit, and compare this to what will happen in space. And we would be actually kind of recreating this on the space version as well, and hopefully able to upload this to the students. So thank you, and I hope this works out for everyone.